Hi, my name is Matthew Carroll. I'm here to talk about plyometrics. In this, we're going to talk about the history of plyometrics and talk about why it's important to be implementing it into your programs. So now what we're going to do is actually talk about the history of plyometrics or shock therapy. In 1966, Yuri Van Hounsky, a Soviet jumping coach, observed that jumpers with the shortest amount of ground contact time, or immobilization phase, displayed the greatest jumping performance. This was referred to as shock training or jump training. This led him to reason that maximal jumping performance requires muscles to be strong eccentrically so that they can withstand the high mechanical loading during the immobilization phase. He believed that if muscles are strong eccentrically, that they will be able to quickly switch from overcoming the eccentric loading to immediately tracting concentrically to accelerate the body in the required direction. However, formerly Purdue University women's track coach Fred Wiltz coined the actual term plyometrics in 1975. The word plyometrics is actually derived from the Greek words plithion or plyo, which means to increase, and metric, which means to measure. Plyometrics is a practical definition. It creates a framework for programming all exercises that we train specific speed strength qualities, such as the stretch shortening cycle, or serve as a progression towards those exercises. It helps teach us to land, produce force, and absorb force. So the goal of plyometrics is to aim at linking optimal strength and speed during fundamental movement patterns. What we want to do is to teach the body how to activate the body's central nervous system and improve its elasticity. By stimulating the fast-twitch muscle fibers, plyometrics also allows us to generate force quickly, efficiently, and also teaches us how to absorb force. There are many reasons why improving your body's elasticity is important. Your body is like a rubber band, and every movement has an elastic component. To stretch it, you need to stabilize one end and pull the other. This stability is the anchor point of your muscles and connective tissues. That allows you to release a powerful amount of energy. By improving your body's elasticity, not only are you enhancing your power to help you jump higher, run faster, and move more efficiently, you also decrease the potential for injury. Elasticity gives you a set of brakes, so to speak, and deceleration tools that help prevent injuries occur by protecting the joints and helping your body endure rapid loads. Some of the important terms that we're going to be talking about plyometrics. The first is speed strength, which is defined as the quick, powerful movement that utilizes the stretch shortening cycle. This stretch shortening cycle is a rapid muscle lengthening followed immediately by a rapid muscle shortening. Plyometrics is defined as a form of exercise that involves rapid and repeated stretching and contracting of muscles. As mentioned earlier, plyometric drills are designed to increase strength for strength and conditioning, used for a terminal phase of rehab, performance enhancement, or injury prevention. Plyometric training utilizes the stretch shortening cycle by using lengthening muscles, the eccentric, which is quickly followed by a shortening movement, the concentric. The eccentric phase is the lowering phase when the muscle lengthens. The isometric phase is the static muscle contraction that acts as the bridge between the eccentric and concentric phase. This is what we call the immobilization phase. And the last is the concentric phase. This is where the phase when the muscle contracts and shortens to move the external load. We will talk about these phases coming up. The eccentric pre-stretch phase has also been described as the readiness, preloading, pre-stretching, potentiation, counterforce, counter-movement phase. These are all different names for this one eccentric phase. Eccentric pre-stretch phase of the plyometric activity stretches the muscle spindles of the muscle tendons units and the non-contractile tissues within the muscle. The proprioceptors of the body include the muscle spindles, the Golgi tendon organ, and the mechanical receptors located in the joint capsules and ligaments. Stimulation of these receptors can cause the facilitation, the inhibition, and the modulation of both agonist and antagonist muscles. The stimulation of components of the muscle, often referred to as the neurophysiological biomechanical response. What does this mean? Well, if the muscle spindle is stretched, there is an increase in afferent nerve firings. The strength of the signal that is sent to the spinal cord from the muscle spindle is dependent on the rate of applied stretch. The faster the rate of stretch, the stronger the neural signal can be sent to the muscle spindles. As a result, a greater efferent muscle contraction, the shortening cycle of the plyometric movement. The other mechanical receptor that plays a significant role in plyometric shortening cycle is the Golgi tendon organ. The function of the Golgi tendon organ is to act as a protective reflex, preventing overcontraction or too much tension in the muscle. Thus, the Golgi tendon organ assists with modulating forces during plyometric exercise. Consequently, the purpose of plyometric training is to increase the excitability of the neuromuscular receptors for improving reactivity of the neuromuscular system, while desensitizing the Golgi tendon organ. Explosive plyometric exercises may improve the neural efficiency through enhancement of the neuromuscular coordination. Therefore, plyometric training increases the neuromuscular performance by increasing the set speed at which the muscles may act. This mechanism results in enhancement of the neurological system to allow neuromuscular coordination to become more automatic. Researchers have demonstrated that this eccentric pre-stretch will enhance the resultant concentric muscle contraction. The pre-stretch phase is predicated on 3 stretch variables: magnitude of the stretch, rate of the stretch, and the duration of the stretch. Manipulating any of these variables will have a significant effect on the amount of energy stored during the eccentric pre-stretch motion. Amortization has been developed to describe the cessation of the eccentric pre-stretch to the onset of the contraction of muscle action. Researchers have used this term to describe this as the time to rebound. This phase is also frequently referred to as the electromechanical delay phase of plyometrics. The amortization phase is the time delay between overcoming the negative work of the eccentric pre-stretch to generating the force production and accelerating the muscle contraction and the elastic recoil in the direction of the plyometric movement pattern, meaning this is the time between the eccentric and concentric movement. This phase is the key to the performance of plyometrics, because the shorter amount of the amortization phase, the more efficient and more powerful the plyometric movement can become. This is because the stored energy is used efficiently in the transition. If the amortization phase is delayed, the energy is wasted as heat, the stretch reflex is not activated, and the resultant positive work of the concentric contraction is not as efficient. One of our primary goals of plyometric training is to decrease the amount of time we spend in this phase. The concentric phase can also be referred to as the resultant power production performance phase. This phase has been described as a facilitated or enhancement phase of plyometrics. These terms actually describe what is happening during the plyometric activity. This final phase of plyometric movement results in the interaction between the biomechanical response that utilizes the elastic properties of the pre-stretch muscles. The blending of these 3 phases to perform a plyometric movement is used to enhance the muscle's power performance. So what we want to do is design the periodization programs and the execution of the actual plyometric drills described later in this lecture is what makes these exercises so effective and performance enhancement. What the last 3 phases I've been talking about is the eccentric is we're storing the energy in the muscle. Amortization is we're taking that and we're putting it into time between. And the concentric phase is that we're actually releasing that energy. Muscle functions in various sporting activities as force absorbers or force generators or shock absorbers, primarily due to the active and elastic properties within our muscle. What we first want to do is teach muscle adaptation. In order for the body to power movement, we have to think about power as in a relative manner. In order to yield adaptation effects in the tendon, we need to have a higher magnitude applied than the habitual activities that we do. Power is relative. For some, skipping would be considered a power movement. What happens is that the tissues will adapt to whatever we do. If we've never do skipping or jumping, and then we perform that, what ends up happening is that we get tissue remodeling. What the muscle does is starts to go into a parallel series and becomes more unified. As you can see in the picture of the muscle fibers, the top fiber is not uniformed. If we can train the muscles, we can train the tissues to be remodeled into a more parallel position like the bottom. What this will allow is the muscle to produce a higher strength and power output. So working with beginners, we want to teach skipping and jumping to teach coordination and also to work on that tissue remodeling. The next phase is important because we want to do is to focus on force absorption. We want to teach people how to land, as discussed in the knee pain lecture. There is a correct way to land and there is a wrong way to land. Before getting into anything complicated, we want to put you in the correct position. The way to think about this is we want to teach the body how to absorb force before we teach it how to produce it. Basically, we are looking at how efficient an athlete loads and absorbs the force as they descend into the jumping movement, while putting themselves in a prime position to reinitiate jumping or running movements. The vast majority of athletes will naturally land stiff-legged in a very rigid manner. As a result, all of the impact is absorbed between the hips, knees, and ankle joints. It is much more advantageous for an athlete to land softly and transfer their force to the glutes, hamstrings, quads, and calf musculature. After we teach the body how to create strength, then we can focus on working on power. Looking at the plyometrics in a program, we have three components to it. We have movement, direction, initiation. Movement is based on the dominant movement patterns being taught within the following movement session. So you want to think about this as jump, bound, or hop. Jump is taking off on 2 feet and landing with 2 feet. Bounding is single leg takeoff with the opposite foot landing. And finally, hop is a single foot takeoff followed by this same foot landing. This is a progression for jumping because the takeoff and landing challenges the tissue. The second component of plyometrics is the direction. Direction is based on the dominant force vectors being taught within the following movement session. This can be either linear, lateral, or rotational, with a vertical or horizontal component to it. Last is the initiation. How is the movement being started? And we want to look at the contraction types. There's the non-counter movement, counter movement, double contact, continuous, or depth jump. In the next slide, we will go over these and show an example of this. So what I'm going to do now is I'm actually going to give the definition of each of these initiations, and then I'm going to have Maggie perform the action. So the first one is the non-counter movement jump. There's no lengthening action prior to the shortening cycle. Two, counter movement jump. A rapid lengthening action prior to an immediate shortening action. So what we're doing, we're going down and then coming back up. 3, double contact. Lengthening action preceded by a rapid ground contact and followed by a shortening action. 4, continuous. Linking multiple stretch shortening cycle repetitions together in a quick succession. 5, depth jump. Lengthening actions preceded by a rapid ground contact from a box and followed by a shortening action. So for the progression, we would first start off with a skip, then a bound, and then what we'd do for level 2 would be actually working on the drop squat. 3, then we'd be working on jumping off of a box. And then the next one would be a counterbalance jump or jumping onto a box. I want to thank you for listening to this lecture, and if you have any questions, you can always feel free to email me at mcarroll@teamexos.com. Thank you and have a fantastic rest of your day.